All right, so today's lesson is combinations of functions and composite functions. In this lesson, you should expect to go over the domain of a function and write that domain in interval notation. Remember, that's using brackets and parentheses. You should be able to perform operations such as addition, subtraction, multiplication, and divisions of functions or on functions. The domain of functions resulting from operations. Okay, so that's going to be a little different than just the domain of a function after you've done an operation. Perform operations such as composition of two functions, and find two functions that would give you the composition of a function that's given. All right. So first off, domain of a function. Recall domain means what are the values of x that I am allowed to plug into a function? Okay. And that's the largest set of real numbers that you are allowed to plug in. In order to find the domain, right, if we have a polynomial, those are really nice. So remember that a polynomial is of the form, we'll say, let me do a0 x to the n, or maybe I'll do an. Let's do an x to the n plus an minus 1 x to the n minus 1 plus dot dot dot. And that goes down all the way to a0. So that's the form of a polynomial. Basically, that just means a number times x to a power plus another number, or minus a number times x to a different power in descending order, right? The powers are getting less and less as you go across. Polynomials are great. They allow all real numbers. When we're going to run into problems is if we have a fraction or a rational expression. That's going to be when we're having a division by 0 problem. And the other problem is when we have an even root, we're not allowed to have a negative number under there. So these first couple examples, the domain is going to be really easy. Right, this first one here is indeed a polynomial. And if it's a polynomial, all values of x, right? So x is all, by the way, we use this symbol for reals, right? That means real numbers. The way to write this in interval notation is to say minus infinity to infinity, right? That's all real numbers. And remember that we cannot use brackets with infinity because we can't be equal. So that's the domain. Okay, so that's a polynomial that works really nice, and there's not much we really have to do there. This next example is a rational function. It's rational because it's a ratio. And you'll notice that in the bottom we have, or in the denominator, we have an x. Well, we are not allowed, right? We can't divide by 0. So what we do is we say, okay, let's say 4x plus 7 cannot equal 0. And we'll solve this just like any other equation. Subtract 7. So we have 4x can't equal negative 7. And then to get x by itself, divide through by 4. So x is not allowed to equal minus 7/4. And in fact, you can plug that back in, right? 4 times minus 7/4 plus 7. That's minus 7 plus 7, or 0. That's our problem, right? We're not allowed to divide by 0. So x can be all real numbers, except it can't be minus 7/4. So how do we write that for our domain? Okay, well, our domain then is from minus infinity up to minus 7/4, including from 7/4 to positive infinity. Okay, so there's a little gap. And in fact, if you look at the plot of that function, it's going to look something like this. where negative 7/4 is going to be an asymptote, and this thing looks something like this, I believe. Okay. All right, this example is where we're talking about a square root. Under the square root, we are not allowed to have anything that's negative or less than 0. So what we do in this case is we say 4 minus 9x has to be greater than or equal to 0. Right? We're allowed to have the square root of 0. Right? That is 0. So it can be equal. Again, solve this just like you would normally. So I'm going to, I think I'm going to subtract 4 from both sides. So I have minus 9x greater than or equal to minus 4. Now remember the rule that if I divide by a negative number, then that flips my sign. So this tells me that x is less than or equal to 4/9. Okay. If it's less than or equal to, that means that for my domain, I'm going to start at negative infinity and I go up to 4/9, not negative 4/9. And in this case, because it's less than or equal to, I will use a bracket. Right. And the last example here under this section, I think there's one more after this one. Yeah. Okay. So this is kind of a combination, right? We have a rational function, but we also have a radical in the denominator. Okay. So we have to combine those concepts now. So under the radical, 4x plus 12 is allowed to be greater than or equal to 0. However, because it's in the denominator, right, our denominator is not allowed to equal 0. So we just take that part away. That's how that's a combination of the two. Then again, solve this like you normally would. So I will subtract 12 from both sides and then divide by 4. And we get x is greater than negative 3. If it's greater than negative 3, that means we start at negative 3. We do not equal, so we use a parenthesis. And we can get up to infinity. Okay. One more example. So here I have, again, a radical, but it is in the numerator this time. And I have a rational function. Let's say function. I gotta be careful with my terms. Okay, so under the radical, right, the 2x minus 7 has to be greater than or equal to 0. Let's go ahead and solve that. So that's 2x greater than or equal to 7, x greater than or equal to 7/2. Right, so I just added 7 and divided by 2. So that's my restraint due to the radical. What about the denominator? Well, the denominator is not allowed to be 0. So here we actually have to factor. We are looking for two numbers that multiply to 10 and add to the middle number, which is 7. Okay. So two numbers that do that are going to be 5 and 2, right? Multiplied together are 10, added together are 7. So this can factor as x plus 5, x minus 2. And then if we have two factors equal to something, or in this case not equal to, we let each of them and solve. Okay. Oh, sorry, this should be plus 2. I don't know why I put minus there. And then you just subtract the constants, so you get x cannot equal negative 5, x cannot equal negative 2. Okay. Now, had those numbers fallen within this restriction, we'd have to take them into consideration. For this, we take whatever is more restrictive. Okay. So if the problem was just this, then the restrictions would be can't be -5, can't be -2. And the domain of this would be -infinity to -5, -5 to -2, and -2 to infinity. However, because we have that numerator as well, this is not the case. Okay. And because of that, we have to take the thing that is most restrictive, which is x has to be greater than or equal to 7/2, right? Because that cuts off all the negative side altogether. So in fact, the domain is 7/2 to infinity. Okay.